Hi guys, so this is the battery I've got around 3 weeks ago, and since then it is cycling here in my hybrid system in the garage. The only user interface I have to check what's going on here with the battery is some information here on the screen directly here on the display on the battery, but it's not too much information which is giving there, and then also some information on the inverter, but that's even less. So what I've noticed is, and what I know from the manual of the battery, it was also then confirmed through observation that this battery with the current settings can actually never balance, right? So why is that? You know, we have a lithium iron phosphate battery here. Voltages, discharge voltage curves on lithium iron phosphate cells are very unique. They are very flat in the middle parts, and at the end of both sides they have some very steep inclines, declines, which are not usable or useful for anything really, because there is no capacity inside those areas. This battery is set from the manufacturer to start balancing at 3.5 volts. The voltage when it's full is 3.65, as you know, per cell, and it takes around 30 seconds probably to reach the maximum voltage once you just start balancing here. So there's no sense in this at all. And this is also what I see through observations, that this pack is not really balancing and the cell voltages are actually drifting away with every cycle. So now, of course, this is an industrial product. They're selling this to customers who should actually not touch anything. This should be plug and play, and you should not be interested to do anything here. But of course, we, especially in the DIY scene, we want to have control of our devices which we buy. I did not get anything with this battery, no battery communications cable, no software to look inside. Even, of course, these products all have something in common. They call it now the Smart Inverter BMS. There's a lot of brands who are producing this. You might know maybe GK, you might know Seplos, Pace. Here inside this one, I have no idea what's inside this one, but they have one thing in common. They may be even produced all in the same factory, and they all have one standard. So what I've done is I went to AliExpress. I was searching for this here. This is an USB CH340 to RS232 cable. It was advertised for Pace BMSs, Smart BMSs, Inverter BMSs. So I bought it, I ordered it, and yeah, we're gonna see if we can establish communication with this battery pack, see how this is set up, and if it then can also maybe change the parameters and try to make this product better and work as it actually is supposed to work. This is the cable which I got. So on one side you have this USB plug here with an integrated CH340 serial chip, and on the other side it's the 6-pin RS232 connector. This is where you see that you have a Smart Inverter BMS built in your device. You have 5 sockets there. Some are RS485, then you have a RS232. This is the middle one, and that is actually that one which is of our interest. Then you typically have a CAN and another RS485. And then on the side there's a state of charge indication, etc. So this kind of BMS you will find on most of the server rack batteries, or then also these kind of wall hung battery packs. Here we are in the Pbms tool software. This is the version 2.5 FN. FN probably stands for final. With this software you can completely access the BMS, and you can also set parameters. And why I'm saying setting parameters, I once saw a video on Andy's off-grid garage channel, and he said that with this software he could only read and monitor but not write. That's why he was using then a software from a manufacturer, battery manufacturer, to write the BMS. And later on in the video you will also see a kind of cut, and I will suddenly be in another software, which is the software from Orient Power, and I will write the BMS with that software. But it is actually not necessary, because what I have overlooked is here, as you can see in the right lower corner, here in the final version of the Pbms tools, you also have the password field. And once you fill in the password here, let's do it right away. This is the password is 1 2 3 4 5 6. You see the field is turning to green, and just leave it like that, and then later on when you go to the parameters, this will then provide the code, and you can also write to the BMS. So we are now disconnected from the battery. You will see here a port COM4. In my case this is already recognized, the stick here, the cable to the USB port. If it would not be automatically recognized, then you might have to try around and set it. Baud rate 9600. This is all okay. We can now press the try connect button here, and yeah, the computer is now connected to the BMS of the battery. We can see here, if we start left upper corner, the voltage, the amperage, we are not charging at the moment, and then capacity values, etc. There is also a battery cycle here, a cycle counter, but this cycle counter, as I saw it until now, is not correct in my opinion, because it is always counting as soon you come from some lower state of charge to 100%, it will count a cycle. But I'm only discharging to around 35% here, so actually I'm only using 2/3 of a cycle each day normally. So I will, in real, I will have less cycles than this is shown. Okay, then all the cell voltages, we have maximum voltage and minimum voltage, and the differential voltage here. On the right side we have alarm status, protection status, fault status, etc. This will then later on show us when we are entering an alarm and when a protection state. When there's a protection state, the BMS will shut down, of course, the battery. When there's alarm status, some other triggers could be set and something could change here in our battery. So yeah, that is it. We are going to wait now until the battery is almost fully charged, and then we will see what is really going on here when it comes to the over voltage protection and balancing. That's the most important what we want to see here today. What I want to say still is I have the link for this PBM tool software and also for the Orient Power battery software linked in the video description below, so you can get it from there. We are now already at 98% state of charge, and this is the area which is interesting me, because we are getting close to the 3.5 volts per cell, and this is where the BMS should start balancing. And you will see, let's just look. Okay, yeah, we have 36 amps going in, so this is about a normal charging rate which I can have on this string. This is a 3 kilowatt peak string. We will hit with that current, we will hit balancing, and the balancing, as you know, is just a very little amount in current, and the time from 3.5 volts until 3.65 volts is just, this is less than a minute probably, or maybe 30 seconds. So in this time nothing can really balance here, but what I'm then interesting is what happens when the charging is finished. Does the BMS then actually continue with the balancing, or does it stop? Because when it stops balancing, then all this balancing is completely useless, and yeah, we have to then do something against this, of course. Okay, let's try to read now the BMS first. And yeah, it worked perfectly. So you can see these are really the standard parameters. Everything is more or less set to maximum. We have charging until 3.65. For me this is all too much. I would want to have this set to lower values, of course. Let's first see what the BMS is doing. I can see here the values for the balancing threshold. This I want to then set to another much lower value and try to set the BMS. We can already see balancing is coming on. Balance, balance, balance. So the first cells have reached the 3.5 volts. Everything is balancing. 4 cells are already inside balancing. So it's 99% state of charge. Just a tiny bit left until the BMS will hit the cell over voltage at the first cell. So you can already see the cell number 8 is almost at 3.6. It just took a few seconds. Now the alarm is there. The current still 35 amps and 3.625, 3.633, and that was it. State of charge changed to 100, and balancing, let's see what was going to happen. Actually, I am surprised this one is as well working a little bit different than other ones I saw on the internet. You see the current is dropping. We still have around 1.7 amps going in to the battery pack, and the cells are holding now, some of them of course 3.5 volts, and balancing is still going on. So charging is not completely finished, but still you can see some of the cells, like cell 6 is 3.37 while the other ones are at 3.5. So it is a little bit out of balance. I think by changing the parameters we will then have a good result. Still 1.7 amps. This is continuing like this. I like that actually like this. That amount of current is keeping the high cells above 3.5, and that's what we want. We want to keep them balancing, of course. So even with this current now, cell number 8 is starting to approach again the 3.65 and volts, and that will then probably, when it hits the cell voltage, then I guess that the charging will be completely finished. So it's a sort of a floating process which took until now around 10 minutes. But ideally, if you want to balance a battery, then this period must be much longer, of course. We're going to see that if we can do something in the parameter setting of the BMS. Cell 8 is now again 3.6 volt. We get a amber box around it. This is the over voltage alarm. The voltage difference is 257 millivolts. The lowest cell is 3.36. So that's quite a bit of a difference, and this is what I'm looking for, that we can improve by setting different parameters. Any moment we are going to reach cell over voltage. And here it is. Charge current is now 0 and charging is finished. So yeah, the BMS is actually still balancing, which is quite interesting because I thought this is not going to be like that. So yeah, so even after some time, so the balancing is still going on even without charging on this BMS, which is great. It's just because the balance current is so small, nothing is really happening and balancing. So this I want to change. Let's go to the parameter settings. I'm gonna set up this pack differently. First of all, I don't want to charge to 3.65. Here it's well enough to go to 3.555. So then, pack voltages, this is again the absolute maximum. I leave this actually like it is because it's not relevant. It will always be a cell which will trigger limitations and never the pack voltage anyways. My balance threshold, this is now again something what I want to change. I want to set it to 3.42, and the millivolt setting should be actually the smallest available, because I want balancing to start, and that's it. The under voltage protection, first of all, I don't want to go to 2.7. Again, I will set the minimum voltage for this pack 2.9, that is deep enough. The release voltage 3.0, and the alarm voltage somewhere in between 2.95. I want to write this now to the BMS, and let's hope this will work. And it is done so far. Great, and we can already see immediately that the values have been changed. Now a lot more cells went into balancing and into the over voltage alarm. So this is really great. I have now set my parameters as I want them in the BMS and not as I was dictated by the manufacturer of this pack. And we are going to watch this now, how this pack is then behaving during the next days, or probably it might even take a week or 2 weeks until this balance situation is improved. So you see, just because the battery manufacturer thinks you are not supposed to look inside this or change anything in the settings, that does not mean that we cannot do it. Of course, you will have troubles if you claim warranty, if you mess up something by setting wrong parameters. But I know that my viewers, they have a great understanding of things like this, and they understand what a lithium iron phosphate battery is, and what kind of parameters have to be set. Nothing is set in stone. Everything is hackable, not really, because it's meant to be accessed. There is all the communication there, and you just need a cable for it, the software, and then you just go on. If you have a battery where you want to look inside but you did not get anything with it, now you know how to do it. I will link this product. This is of course again not affiliated. You just go there, buy it, order it for you, and this is really just plug and play everything, not really necessary to install any driver software or whatever. So I hope you found it interesting. Thank you for watching this video. Please like the video, comment, subscribe to the channel. I see you next time.